This is section 4.2, powers of binomials, or the binomial theorem. All right. Before we get started, we have something called Pascal's triangle that we will look at. This is very easy to start. You start with a 1, and then along the sides, they're all 1s. And you can make as many lines as you like, or make it one line at a time. You will see how easy it is to write one line at a time. And these inside ones are each of these cells inside here are going to be the sum of the two previous cells that are above it. So this cell is 1 plus 1, making it 2. And then this cell is 1 plus 2, making it 3. 2 plus 1, 3. 1 plus 3, 4. 3 plus 3, 6. 3 plus 1, 4. 1 plus 4, 5. 6 plus 4, 10. 6 plus 4, 10. 4 plus 1, 5. 1 plus 5, 6. 10 plus 5, 15. 10 plus 10, 20. 10 plus 5, 15. 5 plus 1, 6. 1 plus 6, 7. 6 plus 15, 21. 15 plus 20, 35. 20 plus 15, 35. 15 plus 6, 21. 6 plus 1 is 7. All right? So you have this procedure. They should be able to set it up from now on. Right? It's very easy to remember the ones on the side, and then realize or remember these other numbers come from adding the two previous ones. All right. Now, where does this come in? Well, what we want to do is expand x plus 3 to the 4th power. And let me zoom in on this. All right. X plus 3 to the 4th power. Let's zoom in some. All right, I think that's about as good as we can get it. All right, x plus 3 to the 4th power. So that would mean you would do x plus 3 times x plus 3 times x plus 3 times x plus 3. Now, some of you might think that's worth the effort, but we are going to get higher exponents than that, which means, like, in fact, the next example is to the 6th power. All right, so what we're going to do is use an algorithm. Right, you can use an algorithm to do this. All right, and here's how it's going to go. You're going to take whatever is here and raise it to the exponent of 4. So it'll be x to the 4th. And then what I'm going to do is write this vertically, and then we're going to put it all together. X cubed, x squared, x, and then x to the 0. Anything to the 0 power is 1. All right? So we take the first term, and we count down from 4. We take the second term, and we're going to count up to 4. So 3 to the 0 power is 1. Then 3 to the first, 3 to the second, 3 to the third, and 3 to the 4th. And then after that, this is where the Pascal's triangle comes in. This is a 4th degree polynomial, or 4th degree binomial, and we're going to find the one with the 4 in it. So we're going to use the 1, 4, 6, 4, 1. All right? And when I say find the one with the 4, we're talking about the edge. Okay? So if I ask you to find one with the 6 in it, it's not this one, it's going to be this one. All right? We just want this row. So this is the second row, third row, 4, 5, 6. All right, so we're looking at the 4th row. Okay? So we do this one. So it's 1, 4, 6, 4, 1. And how we're going to use that is here. Oops, went too far. Come on back down. All right. So we're going to say 1, 4, 6, 4, 1. And then what we're going to do is we're going to multiply that straight across. We're going to multiply it all straight across. So this is x to the 4th, 12x cubed. 6 times 9 is 54. So it's 54x squared. 3 to the 3rd is 27 times 4 is 128 x, and then the last one, 3 to the 4 is 81. We are almost done. This is not too bad. Now we're going to write the polynomial. So these are the terms of the polynomials, and the answer is x to the 4th plus 12x cubed plus 54x squared plus 81 times. That's 27 times 4. I feel like I did that wrong. What's 27 times 4? Let's pull out the calculator. 27 times 4 is 108, not 128. All right. It should be a 108. So it's 108x plus 81. That's a 54, if you can't read that. All right, it says 54 over here. So this is my answer. minus the bad handwriting. All right, so that's what we're looking for. So x plus 3 to the 4th is equal to this polynomial. Let's look at example 2. Example 2. Do the same thing again. So it's going to be 2x to the 6th power, 2x to the 5th power, 2x to the 4th power, 2x to the 3rd, 2x squared, 2x to the 1st, and anything to the 0 power is 1. Now do it backwards. Right? We're going to do the 3, actually this is the backwards one. Minus 31, minus 3y to the 0 power is 1, and then minus 3y to the 1st, then minus 3y to the 2nd, minus 3y to the 3rd, minus 3y to the 4th, minus 3y to the 5th, and minus 3y to the 6th. Okay, so make sure you see this. All right, now we're going to go find a line with the 6 in it, so we're going to use this one. 1, 6, 15, 20, 15, 6, 1. So it's 1, 6, 15, 20, 15, 6, and 1. Now we're going to multiply straight across. So this one is 2 to the 6 is 64. X to the 6. This is going to be 2 to the 5th, which is 32, times negative 3 times 6. So it's 32 times negative 3 times 6. 32 times negative 3 times 6. Yes, I'm using the calculator. Negative 576. Right? I do this. Right? So 32 times negative 3 times 6 gives me negative 576. So it's negative 576. It's x to the 5th and the y. And here, 2 to the 4 is 16 times negative 3 squared. So 2 to the 4 is 16 times negative 3 squared times the 15. Times 15. Oops, is that in there? Yeah, that's it. That gives me 2,160. Make sure you put these negative numbers in parentheses. If you do not, you will get it wrong. So it's x to the 4th, y squared. Now it's 2 to the 3rd and negative 3 to the 3rd. So it's 8 times negative 3 to the 3rd times 20. Times 20. And I've got negative 4,320. Negative 4320. X cubed, y cubed. Now we do 2 to the 2nd, so that's 4, times negative 3 to the 4th, negative 3 to the 4th, times 15. And I have 4,860. 4,860. X squared, y to the 4th. Now we do 2 times negative 3 to the 5th. 2 times negative, oops, I forgot the parentheses. Negative 3 to the 5th times 6. And I have negative 2,916. Negative 2916. X, y to the 5th. Now I do negative 3 to the 6, parentheses, negative 3 to the 6, and I have 729. 729, y to the 6. All right, that's the vertical form. Now you know the final answer I need is 64x to the 6 minus 576 x to the 5th y plus 2,160 x to the 4th y squared minus 4,320 x cubed y cubed plus 4,860 x squared y to the 4th minus 2,916 xy to the 5th plus 729 y to the 6th. All right, that's it. I want you to notice something. The sum of the exponents in each term is 6, right? X to the 6. Remember, if you don't see an exponent, it's an invisible one. So 5 plus 1 is 6. 4 plus 2 is 6. 3 plus 3 is 6. 2 plus 4 is 6. Invisible 1 plus 5 is 6. And that's a 6. So if your exponents don't add up like that, then you did something wrong, right? Again, here, this has an highest exponent is 4. So the sum of the exponents are 4. 4, 3. Oh, I guess you can't see that here, huh? So never mind. All right. So when you have two variables, that works. When you have two variables, it works. Okay? That's it. Sorry you missed the class. All right, bye-bye.